you know how to run some bivariate statistics, such as cross-tabulation analysis, t-tests, and ANOVAs. Now we'll look at Pearson's R correlation, which is another type of bivariate analysis. The same assumptions hold as for previous videos on how to run SPSS tables. You've seen this set of questions before at the beginning of the semester when you may have completed our beginning of semester survey for this class. Today we're going to focus on determining if correlations exist or an association exists between the answers people gave to question 5G, their assessment of their math skills in relation to the average person, and their assessment on question 10 about how concerned they were with success in succeeding in a class such as this that involves the use of math skills. Why would you want to run this type of correlation, in particular Pearson's R? The assumptions are that both of the variables that you're looking for a relationship between are measuring interval level data that is normally distributed in the population. An example would be these two, the assessment of math skills and concern for class. Now, I know that assessment of math skills and concern for class are technically ordinal level data, but we can treat some ordinal level data as interval or ratio level data. Unlike t-tests and ANOVA tables, in this case both variables are interval level data. In the t-test and ANOVA tables that you ran before, the independent variable had to be a nominal or categorical level data. In this case, we do not need to classify the variables as dependent or independent. You're only running correlation analysis when both variables are Remember that you're only running correlation analysis on both variables that are gathering interval or ratio level data. If you were to plot the data points on this, you might find something like this, and that would be no correlation between the two variables. Now, if you saw something like this, you'll notice that the data points are grouped together more in a positive slope, and that would be a positive correlation. But they could just as easily be grouped in a negative slope, in which case now you're talking about a negative correlation between the two variables. So let's look at Pearson's R a little bit more. Let's say that you have a number line that has 1.0 on the right, which is positive, and a negative 1.0 on the left, which would be, of course, negative, and it goes through a center of 0.00. If you saw a cluster that looks similar to this, which is a negative slope, very much lined up together, that would indicate a perfect negative correlation between the two variables. So that would end up with a Pearson's R of a negative 1.0. On the other end, if you saw something much more in the positive direction, again in pretty much a straight line on the way up, an upward slope, that would indicate a perfect positive correlation between the two variables. And of course that no correlation shows up in the middle as a 0. That would show no correlation. The points are plotted all over the place. So let's talk about how to do it. Very simply, analyze correlations, bivariate, and then here when you identify the variables, you don't need to identify whether they're independent or dependent, just identify the variables that you're looking to determine relationships amongst. And then in options, under statistics, it's easy if you choose means and standard deviations. And this is the dialog boxes that you'll see along the way to running your Pearson's R correlations. So let's do it. Could a person's perception of their math skills be correlated with their concern for success in a class that utilizes those math skills? Here we are in our SPSS file. Now you'll do Analyze, and now you'll go to Correlate, Bivariate. You'll identify the variables that you want. So here's math skills, and then concern with this class. Options, choose means and standard deviation, continue, OK. And this is the data that you'll see. Now the way you read this, here's the mean for math skills, and here's the mean for concern with class. There's not that much of a difference here. But if we go to this correlations table, now you can read the table to say math skills. How is math skills correlated with math skills? What a surprise. That's a perfect 1.0 positive correlation. The same thing with concern for class. With concern for class, that's going to be a 1.0 positive correlation. But now if you look at math skills in comparison with concern for class, how well are those correlated? You see a negative 0.138. More importantly in this case, notice that significance is greater than 0.05, so it would indicate there's no significant correlation between the two variables. But you'll notice this negative 1.38 is identical to the negative 1.38 with math skills and concern with class. And that should be obvious that they're measuring the same, that the calculations are identical on here. So they will be identical numbers as well. And all the N tells you is how many people were included in the analysis. And if you were to plot this on a scale, you'll see that really there is not a very strong correlation between the two variables. Processing time. When would you choose to run Pearson's R correlation rather than t-tests or ANOVAs? Which of these represent a stronger correlation? It'll be easier to answer that if you can also answer this question. What do the following Pearson's R statistics tell you? Remember that a 0.00 is no correlation. A 1.0, the closer you get to 1.0, the higher or the stronger the positive correlation, and the closer you get to a negative 1.0 would indicate a stronger negative correlation. And then what steps would you follow if you were to run Pearson's R? Those would be analyze, correlations, bivariate, and then identify the variables, and under options for statistics, choose means and standard deviations. Now, if you need to run analyses on two variables that are gathering independent level data, then you would use Pearson's R.